I don't think too many people still coming. So should we go ahead and start?
Okay, it's time. So let's start. So welcome to the HOTRFC session, and brought by Liz and myself. And it's my great pleasure to be here to help co-chair this session. And many thanks to Liz, and who has done great work to put everything together. So it's very nice. And we got this note well. So if you are first time in IETF, please do go through these slides. And since you are partitioning IETF, and you need to follow the procedure, IETF procedures and process and policies. And you need to be aware of these IPR issues. And so if you have any questions, concerns, please come to us and come to IETF offices, and there will be people to help you. And there are also some materials so you can go through. And we also got this note really well. And it's about more about this behavior, and so anti-harassment procedures. So please be friendly and respectful to other people's work. And again, if you have any concerns, please do raise it, and you will be taken good care of. Yeah, so here's some meeting tips. And please do sign in and with the light meet echo. And so you will have your name there. And since we don't have the mic time, the question time, and you don't need to use the on-site version. And we do have 3 remote presenters. So please make sure your audio and video are off, and unless you are presenting. Next. And the ground rules for this hot RFC. So in this room, in this session, the RFC stands for Request for Conversation. That is, you got a great idea, and you come here and you present it, and you got people who are interested in your idea. And then you could work together and progress your work and a draft and then RFC. So that is the whole purpose of here. And for every presenter, please, you only have 4 minutes, and there will be a timer. And so every presentation will go from go to please plot. And that will be the next slide. So something like this. So we will go very strict. And there will be no question. So, and again, after this session, and you go together and have the conversations. So now it's Sunday night, And we are going to have this short break before this long IETF ahead. So let's enjoy. Let's start. Welcome the first presenter, Mattia. Floor is yours.
Would you like the clicker, or do you want to just say?
Oh, I can just say. Okay. Thank you very much. Can I start? Yeah. Okay. Hi everyone. I'm Mattia Montagna from Quantum Bridge Technologies. I'm here to look for collaboration and support for the development of symmetric key exchange, the development and standardization of symmetric key exchange. So the idea of developing symmetric key distribution system that only rely on symmetric cryptography, so they don't make use of any form of asymmetric encryption. So let me give you a bit of background and information that justify or support this effort. Asymmetric key cryptography is a very versatile and powerful tool for key distribution over the internet. However, it comes with a few shortcomings. The first one is that it is generally computationally very intensive. And the second is that the security of asymmetric cryptography rely on mathematical assumption. So the security rely on the difficulty of solving certain mathematical problems. The arrival of quantum computer is now jeopardizing the security of asymmetric encryption because those machines are able to break most of the mathematical primitives which are behind asymmetric cryptography. As a consequence of this, there are several government institutions, organization institutions, and in general consumers of cryptography that are requesting new standards for symmetric key exchange. So key exchange which are only based on symmetric cryptography. At the same time, system integrator and system architect need to abstract from the symmetric key distribution system to avoid their system to depend on specific vendor. So we think that there is a need for a standard board at the symmetric key distribution exchange level, so developing standard for new symmetric key exchanges. And also, we think that it's important to standardize the interface, let's say, between those symmetric exchange and the application consuming them. At the moment, there are no standards for symmetric distribution mechanism, and there are few standards for the interface. For example, the HCGS QKD 014. However, normally those are very high-level protocol that are not suitable or for let's say designing low-level API. Next slide, please. So what we suggest here is to develop a framework and possibly standardizing some protocol for key distribution only using symmetric cryptography. So we would like to have support in defining system level API that allow to decouple the symmetric key providers from symmetric key consumers and guarantee interoperability between those systems. We would like also to provide standards for symmetric key exchange and the security within it. So define a set of security rules that allow the definition and the development of those symmetric key exchange. Next slide, please. So the next step, we're looking for support to organize a BOF meeting during the next IETF in Vancouver. We built a mailing list that is here on this slide, and we encourage any interested people to reach out with ideas, comments, and feedback about this effort. And we also organize a side meeting for Tuesday and Wednesday during the IETF here in Brisbane at 3 p.m. And so we look forward to feedback, comments, and any collaboration or support in this effort. Thank you very much.
So next speaker, Lin Zhe.
Hello, everyone. Thank you. Hello, everyone. This is Lin Zhe, and my topic is DDoS trends and defense issues. Let's start it with the attack trends and problems. There are 8 million DDoS attacks happened in the first half year of 2023, which means the DDoS attacks happens more frequently. And also, it shows the future of hypervolumetric. The largest attack record in 2023 is about 2 million requests per second, almost 8 times larger than 2023 record. So this kind of high volumetric cost high defense costs. To counter this kind of DDoS attack, long-term purchase and the operation of large-scale DDoS defense resources come at a very high cost. And also the attack becomes more intelligent. In 2023, more than half of the DDoS attacks use more than 2 vectors. And also, this is an example of the fast flooding attack. This kind of attack can suddenly spec to a high level for a short duration, which is hard to detect and also hard to defend. And also there are many new means of DDoS attacks, such as some attacks based on HTTP2 or CoAP. So it's really hard to detect the new means or intelligent ones, also for SP and for the enterprise. So there is a case if a fast flooding attack is happening from the network, from the operator to the enterprise. For the operator, because of the sampling-based DDoS detection, it can't find the attack in time. But for the enterprise, although it can detect attacks in seconds, but because of the limited resources, it can mitigate the attack. So from the enterprise to the operator, which indicates the DOS client, and to the server, we think the enterprise should make a mitigation request to the server, and the operator can acknowledge the attack and develop mitigation strategies, and then make the response. So that's very important. There are 2 key elements of defense. One of it is visibility. The other is defense results based on the visibility, which means all the useful information about the defense scheduling strategy. They can be the attack features, network telemetry, information, or DDoS threat intelligence. And based on this kind of information, they can do the schedule strategy and use the defense resources to do the mitigation. So we think collaborative mitigation can help expand both the visibility and increase the available defense resources. We have noticed the DDoS open threat signaling, and it has defined the protocol and the data model for collaborative mitigation during the transfers, but we found there are also some shortcomings. So that's why we are doing the work with the DDoS mitigation, collaborative mitigation, and there is 2 jobs of our works. If anybody is interested in, please contact me. Thank you.
So next speaker, Xiaohui Xie, please.
Hi everyone, this is Xiaohui Xie from Tsinghua University. Today I'm very excited to share you about our thinking about how to leverage the large language model for networking. So here is the background. As we know, the emergence of the ChatGPT has marked the beginning of the rapid development era for the LLM and the generative AI. From a report by Yahoo, we can see that ChatGPT achieved like 100 million MAUs within 2 months, faster than TikTok. And nowadays, numerous LLMs and related effective applications has been proposed. And we have witnessed the LLM show the remarkable capabilities in concept understanding and also the mathematical reasonings. And this one is Solar, as we recently released by the OpenAI. And from this application, we might say the large language model has a certain level of understanding of the physical principle. So we are glad to see that the application of LLMs in the networking field is receiving increasing attentions. So take the HotNet last year, for example. So there are 9 sessions in HotNet last year, and two of them focus on the large language model. One discussed can LLMs reason about networking problems and their solution, and another one discussed can LLMs manage networks. And one interesting work is that Prosper there, in this work, they use the LLMs to understand the IETF protocols using the RFC files. So it's quite related to our society. Okay, so to enable better use of LLMs in networking area, we abstract an architecture, and I call it LLM in the loop architecture for networking. So several components, including in this architecture, includes the data and also the prompt engineering process and the fundamental LLM solution tools and the answer generated by the fundamental LLMs, and also then the validation before the actions. And we also have a small loop to ensure the quality and the safety of the proposed architecture. Okay, so of course there are plenty of challenges we should address in the future, including how to represent the heterogeneous network information. Like in network, we have the runtime, a real-time traffic data, the binary traffic data, and also the static documents, and also how to make sure LLMs know their role in a specific task. And one important thing is to ensure the correctness and the safety of the LLM generated output, such as the network management commands. And also for the future, maybe we can develop LLM-based autonomous network systems. Okay, so this field is full of opportunities and also challenges. So in this IETF this time, we organize a side meeting in Wednesday afternoon, 4 p.m. So if you are interested in this topic, please join us and provide valuable suggestions. Yes, that's all. Thank you.
So next one is Dongyu Yuan, please.
Okay, hello everyone. This is Dong Yuan from DT Corporation, and today I want to talk about something about PaaS versus CATO, standalone service identification in IP in routing networks. So next slide, please. So the first thing I want to address is maybe, as we may admit, a promising and possible future about IP networks and service infrastructure. So the applications are becoming more and more complicated and flexible, and one application may involve several microservices that may cross multi-domains and maybe even multi-providers. These scenarios may include the classic north-south scenario and the more and more incoming east-west traffic. So the main problem is how to identify and provision the whole life cycle of the workflow of a single application and service. So next slide. So here I'd like to quote the classic saying with the upcoming cloud native era that ports and containers appears to be the cattle, while the traditional conventional VMs and physical machines are cattle, are pets. So as for IP networks, the IP addresses are utilized as well as the cattle, while the ports of connection to services, which is reckoned as the paths. So as we think that a new agile and wise path, that is a standalone service identification, could be utilized for our IP networks. And on the right side of the slide, here is the show of the H2 open resource realization of service mesh. Here we can see many proxies, many sidecars. There are instructions of the traffic flow. So this is kind of bureaucracy. And next slide, please. So as we mentioned here, we are looking forward to a unified and general interface between our IP networks and app layers. That we may call it a standalone service identification. It may be designed for the full circle of our service. And it may be designed to have the features of cross layers and as a reflection of both demands and service conditions. And next slide. So here is the main content about this in our HOTRFC, and we are also planning our side meeting on Tuesday night at P6 to 7 in the evening. So if anyone are interested in our topic, so please free to join us, and we are looking forward for collaboration and more discussion. Thanks a lot.
So our next speaker, Frank Xia.
Okay, hello everyone. It's Liang Xia from Huawei. You can call me Frank. Okay. Today we want to bring a new requirement, a proposal to IETF, which is about the threat surface management of the network element. So let's see some background. Firstly, we all know that currently the network infrastructure security is more and more facing more and more challenges right now. We can see that in addition to the traditional way that the attacker can attack through the security devices and to hacking the customer's business system, to do a lot of bad things. Currently, there are more and more attacks. They just attack through the network infrastructure. Through the router, through the switch and IoT devices. They control them and they can direct the traffic, they can make a lot of things and they can attack the business system as well. So we think that this is on this trend. So we can see a lot of examples that our very big infrastructure provider, like operators, like government, the bank, or the energy company, or some manufacturer, they all facing different kind of risks happened because their network infrastructure is being attacked. You can see a lot of examples like the ransomware attack, or the internet outrage, or the manufacturer's production network outrage. All of these things is many of them are caused by the network infrastructure security problem. So so this is background. So in this page, I just want to give a very quick overview of for example, take the IP network as an example. There are a lot of threats to the IP network. We can categorize them into four types. Type 1 is about the boundary. The boundary can be invaded and can be the invalid access and so on. And for our draft, for the network element, they can have some vulnerabilities and be attacked through their external face, and they can have the weak configuration and their low availability and supply chain attacks and more. And for the control plane, data plane threats, the routing protocol problems or the traffic interception, right? And for the management, they can also be attacked. So, and we also studied that IETF has done a lot of work in different working group to take care of the network infrastructure security, like the RATs, the reboot attestation, like SCIT, supply chain security, the network inventory management, and so on. Of course. But anyway, we believe that the visibility, the network security visibility, is very, very important, a key factor for all this work. If we can see that we can do something to protect our network infrastructure. So our very specific requirement or proposal is network element threat service management. Okay, I think. Okay, here we have two concepts. One is defined by Gartner. It's the external attack surface management. And another one is the network element threat surface management. I cannot go into detail. But basically, the threat surface is the potential attack surface. So we want to define what is the threat surface and modeling them, and we can manage them. So this is our draft, and you can contact me. Okay, that's all. Thank you.
And for people who are standing outside, we still got some chairs. If you like, you could come here and for people outside the room. So next speaker is Manon Fontaine.
Hello, everyone. My name is Mani Fontaine. I'm the founder of HushMesh. I want to give you an update on the Universal Name System and the Universal Certificate Authority. We introduced the concept at the previous IETF meeting, and we've made some progress since. Why are we doing this? Well, we realized that, in fact, the web itself, the architecture of the web itself, is a cybersecurity dead end. Because there are, in the architecture, there's two fundamental things that you can't verify: the insiders and the relational links. You just have to trust that those relational links are maintained properly and that the insiders are just behaving properly. So we wondered, is there a blueprint? Is there a way to create a globally verified information infrastructure like the web, but that would have zero trust built in and that would extend at internet scale? Turns out that there's a very interesting technology called confidential computing, trusted execution environments, that has been available for a few years now. And what it does give you is this fundamental property of being able to remotely verify the chip itself, the hardware, and then the software that runs on it within the enclave, within the trusted execution environment. And if you take this piece and you start leveraging it extensively, you end up with a blueprint that looks like this, where you have entities, Alice and Bob, can be anything, people, organization, digital things, physical things. Instead of connecting to some enrollment server, identity server, authentication server, they connect to one agent, their own specialized agent, that software agent that runs in a TE, and that agent does enrollment, identity, authentication, authorization, all kinds of things. And then those agents, to connect to other agents, need to find a path, a secure, verified path to be able to do automated key exchange. And that can be achieved with a chain of trustees, as we call them, which are other software actors that runs in these enclaves. Turns out that you create the pattern or the blueprint the right way, you end up with a hierarchical, recursive pattern where the parent trustee to multiple children can actually be used as a registration server for aliases and can be used as a key exchange mechanism so that you can actually automate key exchanges between any two agents without any human in the middle at all. And then you take these blueprints and you can start scaling it out by stretching your chains of trustees, and you end up with a hierarchical structure that looks very much like the DNS, but that is only running across verified confidential computing machines. And then at the bottom, you can start deploying different agents for different types of entities. And then you can stitch together these chains of custody where only the rightful entities running all in confidential computing environments can actually exchange data with a fully automated key exchange across the trustee network. I need to rush a little bit so you guys will. So this is the UNS and the UCA. But anyway, when you take the diagram that you had before and you fold it onto itself, you see that you end up with a network that has indeed no humans at all, no insider, fully verified. So you have universal zero trust across everything. This is a snapshot we built. So the update is that we built first version of this, we deployed it, and we are testing it right now. You end up with an information space that is fully encrypted with keys that no humans have access to at all. Only the verified machines have access to the keys. Interesting enough, it also solved for people who are in the identity space, decentralized identity space. You can see that it collapses into a three-party model with actually full zero trust interoperability between any type of credentials that you would flow through that network. So side meeting tomorrow, P67, if you guys are interested, at 2 p.m. Thank you.
Okay, so next speaker is remote speaker, Robo Muming.
Good morning from Germany. Good evening, Australia. I hope it works. I'm a little bit in the phase before UNS UCS. I'm trying to address the current situations we are having with certificates and root certificates, especially. If you can go to the next slide, please. The next one, please. So the whole slide set is for you to have a look at later, and I'm trying to cover all, and I'm not trying to make sure I'm trying to make sure I got it even agnostic to the slide I'm on. That's a better description. So I had some special experience with rootkits in the past, also private as professionally, and during the different vectors they used to inject into the system, the later stages were self-signed and custom certificates. And those enabled those attackers to gain control over a lot of aspects within the machines, within the machine, and enabled them to establish a whole ecosystem of spoofed, fake man-in-the-middle infrastructure. To combat that, please the next slide. To combat that, my suggestion would be to find a way to, in the meantime, until we find a UNS UCS approach, to hash the certificates of roots of certification authorities, and find a way in a dedicated top-level domain like certs or cert, or another one which might be used to store a text and or a pointer in terms of the certificate, where you can query and verify the root certificates within a given certificate store. So if you go to the next slide, that would mean that in a case of or in a natural environment, you would have a situation where the application and or the operation system would query the namespace or the top level domain with the certificate, check if it's getting a reply, see if the hash is matching, and that would be a positive feedback. If there would be no feedback, it would be potentially malicious or potentially fraudulent. So that would be a way to implement it. There are a lot more stages which I'm would like to work on. Maybe maybe somebody would be interested in that. And my personal goal for this session would be, and the next slide, please, is to find somebody that will work with me on creating an internet draft or a draft for an RFC maybe later. So, and yeah, if you're interested, I would like, next slide, please, to contact me. And I'm a bit faster than I actually anticipated. But if that's something that interested you or interests you, please feel free to contact me. And have a great day, and greetings from Germany.
Thank you. So our next speaker, Timothy Horban.
Hello, I'm new here. So I prepared this before I'd ever been to an IETF. So just a quick check. UN Conference on Trade and Development, United Nations sites, estimates the total, I'm trying to find the figure, the total expenditure on delivering sustainable development goals to be between $5.4 trillion and $6.4 trillion annually. That means that we need to build peace industries, which means that that's the underpinnings for that is somehow to build humanitarian ICT supports for technologists who work within the peace domain, as this distinct to foreign affairs or defense or commercial. Next slide. So yeah, so you know, there's a whole bunch of stuff about we are all human. How do we support our humanity in all of its diversity? And to build the technology to do that, it's different to other sectors. And the derivatives are different if we don't have those supports. Next slide. So as a class of worker, like under the international humanitarian law, there is a class there for doctors and other types of international humanitarian, specialized categories and requirements. There needs to be someone who can make sure that the refugee credential on the phone still works when the network's potentially being turned off. How do we create a class of worker that is about humanitarian ICT specifically? Next slide. There's a whole bunch of different types of views in the United Nations Digital Transformation Agenda and etc. around human-centric internet or people-centered internet or sustainable intelligent internet or all sorts of different names and competing views. But if we can't build the underlying humanitarian infrastructure to make sure that our human rights are able to be independently supported from commercial products or foreign interests, irrespective of whether or not different countries aren't getting along, then how do we sustain our internet? And I think that this is a new problem because we didn't need it in the industrial era. But the information era towards the knowledge age is changing. Next slide. So the idea is to create some sort of informational, I think it's called an internet draft, where we can try to support our colleagues in other areas to have the technical community speak about what their view is on what the specific way of classifying humanitarian ICT workers, ICT infrastructure, the whole ecosystem as is required to support the delivery of sustainable development goals should mean. And so I thought I'd raise that and ask that the community reach out and help, make some progress. Next slide. Some links. I made a GitHub repo. There's a draft. It's not very good. And I'm still working on it. There's a related topic that's next. And so called agent discovery profile, which is a more concrete, concrete type of thing to do. And the action item would be to look at trying to do a side manning. As I said, I'm new here. I'm not trying to figure out how it fits in the IETF process and all the rest of it. I'm learning as I got here after I did the slides, etc. Nice to meet you all. Thank you.
So you can go next.
Agent discovery protocol. So we all understand what an agent is from an internet perspective. Next slide. So the idea is that there's a basic file attached to a domain and the file secured that could have particular types of information. So if it's gemini.google.com, then it might grab the metadata out of these images and give you the information about the fact that it came out of generative AI, just from the metadata in the file. Next slide. I care about human-centric AI, as I called it, in W3C world, where I was working. I am working. And so that's where people own all their own data, and it enables the means to be able to create sophisticated personal ontology supports, which is complex. But that's all too hard for most people to do, and there's a lot of people fighting over who's going to own the special identifier or whatever. So the idea is to just use the domain name, but to not store anything particular in a domain name, just provide the file that's like sitemap.xml or robots.txt that is RDF based, thereby enabling a graph. It enables you to link to whatever service it is. And also if you change that service or migrate it somewhere else, you're able to change it. From a personal standpoint, the idea is that the registrar should theoretically be able to do it for you if you can't afford the hosting service. RDF comes in a bunch of different serializations. It's kind of how the web of data works. There's a lot of people who don't know very much about it. Highly recommend having a good look. Next slide. In organizations, the theory would be that this one file might say it's a humanitarian website and it might have a credential attached to it. So therefore, don't turn it off if there's a network outage or if there's emergency bandwidth after a thing or whatever. You might have one that says it's an adult website, which could help with network management in schools. You might have one that says there's a different endpoint for kids and one for adults on the video side. You might have one that says, here's the Sparkle endpoint for the library. Because it's RDF, it's quite extensible. It's not intended to be a database, it's just one file, public file pointing to different endpoints. But to secure that file somehow, and to make it really easy to be, so that, particularly with human beings, that you bring human beings and DNS system into a sort of, human-centric AI internet, whatever that is. Next. So I know that there's WebFinger. I think it's different to WebFinger because it's not JSON, it's RDF, and there's some really good, important reasons why it's different. There's a thing called WebID, which is really, a lot of the inspiration comes from that. WebID used to be baked into a TLS certificate and be a FOF document that's used in standards such as Solid, which is now led by Tim Berners-Lee, to create a personal data storage system with pods. European organizations called MyData have a range of different implementations also. But the WebID method is kind of considered to be separate, something that this thing would point to. FOF is old. There's a couple of different things. I don't quite know the exact, I'm new here, I'll say it again. And there's some sage wisdom. So a couple of issues. One, I've got 5 seconds. Humanitarian ICT, a mechanism to instantiate it and support for natural human beings as first-class citizens on the net.
Okay, thank you. Well done. So our next speaker, Matt and Marcos, and I think they have a couple.
Hi, everyone. I'm Matt Joris from Meta, and I'm here to talk about adaptive video on the internet today, how that intersects with traffic shaping, and how we might solve some of those problems with the IETF. So this is a really basic overview of how ABR video works today. So pretty much any video service that uses ABR, this is roughly how it works. So a user uploads a video. The video is broken down into individual segments of maybe a few seconds long, and the server will encode many versions of that video. Each one of those corresponds to a different quality or quality lane, from maybe 0.5 megabit per second up to 20 megabits per second. That often have a resolution associated with it. And then the client, so the video player, will fetch these segments individually as the video goes on, try to measure the download speed, and then adapt the bitrate it's fetching based on its notion of how good the network is. So it's probably not a surprise to anyone in this room that video makes up the majority of traffic on the internet these days because it's very popular content. And so because of that, operators will introduce things like shapers into the network. Now, they primarily do this to limit data because, video makes up most of the traffic. And so to limit traffic, they have to limit video. And conveniently, because these ABR mechanisms, they have a natural way to try to limit data by making the client limit it for them. So in this case, the operator introduces a token bucket filter of 2 megabits per second into the network. And the desired outcome is that the client's going to choose that 2 megabits per second quality lane. And so it does this basically by, arriving at the fact that there's a limit on the network. And so it stalls, and then eventually at the end there gets a different quality level that's below the 2 megabit per second shaper. So this works, but it's kind of trying to achieve a second order outcome, which is data limitation based on a network thing and introducing a artificial limit. And so this has a lot of problems in practice, not least of which the ABR schemes aren't perfect, but also congestion controllers aren't very good at dealing with these things. So a solution we think is really compelling and is really quite simple is if the operator really wants to limit data based on limiting the quality, what if the video player just limited the quality directly? So if it knows that on this network that the max it's going to be able to achieve is 2 megabits per second, what if it just ignores qualities higher than that? And so when it does that, what happens? Well, it basically the same thing happens, except for there's no stalling because it will never try to get a quality that's higher. The operator can remove that token bucket filter. the network can be used more organically rather than hitting artificial limits, and this leads to overall better user experience and better performance. So all this leads to Scone Pro. This is formerly known as SAD-CDN, was presented at Dispatch a couple IETFs ago. We've had side meetings since then, and also some virtual side meetings. And at this IETF, we are having a BOF. And so the basic idea with Scone Pro, which is securely communicating network properties, is to explicitly cooperate. So if you have content providers and you have networks and you have CSPs that are all part of this, why don't they just explicitly cooperate in a standard way and encrypt that standard communication, and for the purposes of achieving something like we saw in the last picture, which is that you can not have a traffic shaper and have better outcomes for users. If this sounds like something that's interesting to you, we have a BOF, a non-working group forming BOF on Thursday on session 1. And you can also find me or Marcus anywhere in the hallway, or reach out to us via email. Thank you.
So next speaker is a remote speaker, Adrian Gropper. Yeah, please start. Yeah.
Okay. Hi. The topic for this has to do with the intersection between large language models and personal data. Next slide, please. There are a number of standards that relate to agency or delegated authorization. And we're talking about these in the context of personal data as presented to GPT-4 or Gemini from Google, etc. Next slide, please. This is easy to understand in the case of medicine, where the large language models have proved already to be much better than doctors at answering questions, because there's so much medical knowledge that they can mine in the public domain, and they're so good at processing large amounts of input data. Gemini from Google allows 1 million tokens, for example, which is larger than most people's health records, even if they're ill. Next slide, please. So what we're looking at is how to, what are the standards at the interface between somebody's health record or other large personal data store and these large language models. So some people use the term prompt engineering for this. And again, I won't go into the details, but there is basically two possibilities. One of them is that the large language model is able to access the data directly under its own control, under its own authorization server, or that an authorization server whose policies are run by the individual provides this data to the large language model, possibly with the prompt engineer in between to add some obfuscation in some cases or synthetic data, etc. So next slide, please. So we're talking about building a standard on top of a IETF standard that was just approved in the last couple of days called GNAP, Grant Negotiation and Authorization Protocol. You'll see a link to it in the slides at the end of the slides, and there's a meeting on it on Wednesday. So GNAP does not consider any particular use case, such as the one we're talking about here of authorizing access to personal data for a large language model, or building communities that would advise people on how to run and what policies to use to control such access. Next slide, please. There are a number of other slides in the deck, which I obviously won't go through, that show different use cases, but you can see on this slide the general idea that the user has an agent and the agent controls both an authorization server or a personal digital agent and the prompt engineer. And these are the relationships that we are trying to get input on and charter a work group for PDAP. There's a pre-work group mail list, pdap@ietf.org. Thank you. All those links are in the slides.
Thank you. Okay, our last speaker, Neil. Yeah, you are ready.
Yep. Hi, I'm Neil Krawitz, and this is Vita, Verified Identity Using Distributed Authentication. Next slide. Basically, we need a way to reliably attribute content to an author. This would allow us to answer questions like, is it authentic? Was it altered? And who created this? It should also address issues like false attribution and non-repudiation. Next slide. There are a few existing approaches for this problem space. However, they each have their own limitations. For example, most blockchain-based solutions cannot scale to extremely high volume. And C2PA's corporate-driven solution is completely built on trust, making it trivial to generate authenticated forgeries. C2PA also requires registered X509 signing certificates, and those can cost hundreds of dollars per year. Next slide. My proposed solution is based on DKIM, which uses a public-private key pair to authenticate emails. Frankly, I think the anti-spam developers got it right. DKIM signs emails with the private key, then the recipient receives the email and retrieves the public key from DNS for validation. Next slide. Vita uses the same approach, but rather than signing email, it can sign pictures, videos, documents, or any other kind of media. The signature only needs to contain the host name for the DNS lookup, optional parameters for generating the signature, and the small cryptographic signature. Next slide. Because Vita is linked to the DNS record, it links attribution to a host name. Authentication, validation, and non-repudiation come from the use of public-private key pairs. In addition, DNS provides a distributed environment and privacy through indirection. There's no dependency on a single vendor, and the signer cannot track usage. Next slide. So what I need is some help. I need help ironing out the implementation details. I need help navigating the RFC submission process. And I'm used to writing really long essays, so I need help converting my novels into the succinct format that's used by RFCs. And while I am a programmer, I could use some help creating a wide range of tools and libraries for other people to use. Last slide. Again, my name is Neil Krawitz. This is Vita. There's my contact information, and I thank you for your time.
Okay, that's it. That concludes our session. And again, thanks to all the speakers, and thank you here. Enjoy the rest of the IETF week. Iris. Good, good. I think it went well.
Yeah, thank you so much. You did a great job.
Thank you.
Are you doing all this?